Alright, this is 3.5 in Advanced Algebra 2, solving quadratic equations. Today there's three different ways to solve quadratic equations. You could factor, which honestly you can't always do that. You know, you can't always find two numbers that multiply together to be blah and add together to be meh. Complete the square, which can happen every single time. Sometimes it's really easy to do, sometimes it's a pain in the butt. And the quadratic formula, which works every single time. It's just, it takes a lot of punching and substituting in to use the quadratic formula. So we're going to learn the best time to do each. So here on number 1, they say solve the following equations by the three methods, if even possible. They want us to take this equation and factor it, complete the square on it, and do the quadratic formula on it, and just see which one was the easiest of the three to do. So let's try to factor. Again, this guy might not even be factorable in the first place. So let's check it out if we talk ourselves through our factoring cheat sheet. GCF. No, this guy's already equal to 0, so no GCF. You can't be a difference of squares because there's three terms. If he's a perfect square trinomial, first guy's got to be a perfect square. It is. Last guy's got to be a perfect square. It's not. So it's down to easy or frowny face, and this is an easy situation. So I'm looking for two numbers that multiply together to be 7, add together to be 8. That'd be 1 and 7, and that would factor to be x plus 1 because it's easy factoring. We don't have to go through all that work. Times x plus 7 equals 0, and then x would equal negative 1 or negative 7, and we put our solutions in a solution set. That was pretty darn simple. Now let's do the same thing by completing the square and realize we should get the same answer every time. It's like we're solving this more than one way. So to complete the square, I know it's been a while since we've done that, but that's where you want to get all. So let me just write this down. You don't need to write this, but here's the actual equation that we're working on. Again, you don't need to have that written down if you don't want to. But the idea on complete the square is get all the stuff with the x's on the left side and get all the constants on the right side and set it up with some blanks. So I'll have x squared plus 8x plus blank equals, bring that plus 7 over to the other side by subtracting it and throw a plus blank on there. And remember, to fill in the blank, you need to take half the b value and square it. I should back up and realize to complete the square, there's one rule that has to happen. The a value has to be a 1. Right? So the a value is 1 right now before we can complete the square. And then to fill in the blank, you take half the b value, which in this case would be 4, and then square it, and that would give you a 16. That goes in the blank on each side. The reason what we just did is we have completed the perfect square trinomial. That's why it's called complete the square. We have just completed the perfect square trinomial. And this guy now easily factors to be square root of the first dude, square root of the last dude, sine from the middle, quantity squared, and that equals just these two numbers added together, which is a 9. And now we use the square root method to solve. We could square root both sides, and that would give you x plus 4 because the square and the square root cancel each other out. And then the trick to completing the square is you'll get a plus or minus over here, and the square root of 9 is a 3. And now we just got to subtract 4 from both sides. So x will equal negative 4 plus 3, which is a negative 1, or negative 4 minus 3, which is a negative 7, right? Because you have plus or minus 3 over there, and there's the same two answers that we got before. And I hope you realize so far that factoring was easier than completing the square on that guy. Well, we could solve this quadratic equation by the quadratic formula if we wanted to also. I have that typed out for us here just in case you forgot. It's something you need to get memorized. But I've always been a fan of identifying A, B, and C off to the side when I do the quadratic formula before I even get started. So A is 1, B is 8, and C is 7. And now I just substitute in. I need the opposite of B, plus or minus the square root of. I do this b squared. I go ahead and literally put 64 because that's what b squared is, minus 4 times a times c. I always use parentheses, all over 2 times a. And now I need to clean up what's called the discriminant. That's this number underneath here. I just let my calculator do all that work for me. I just literally type 64 minus 4 times 1. I use parentheses times 7. And that gives me a discriminant of 36, which is nice that that's a perfect square. square. So you have this situation going on for you. And now I can actually take the square root of 36. It's plus or minus 6, hence the old plus or minus right there. And now here's what you really got. You've got negative 8 plus 6, which is a negative 2, over 2. Or negative 8 minus 6, which is a negative 14 over 2. And these both simplify to be negative 1 or negative 7. And there's our solution set again. Hey man, I solved that quadratic equation 3 different ways. And I hope you realized that since this was easy factoring, easy factorable, that was the freaking fastest way to get it done. But all of them work, you know. So factoring was probably the best choice there. Let's try another one. They say, hey, let's try to solve this quadratic equation. Well, let's realize he's equal to 0, and let's see if I can factor him. No GCF, perfect square trinomial, nope, this is a bad boy, so he's in the easy category. Two numbers that multiply together to be 2 and add together to be 4. So multiples of 2 are 1 and 2. And realize they'd both have to be positive, they can't both be negative. These do not add together to be 4. So there are no numbers that multiply together to be 2 and add together to be 4, meaning I can't factor this. This is not possible. It is not possible to factor this particular quadratic equation. So I have to use one of these two other methods to get it solved, because I can solve every quadratic equation. So let's complete the square on it. X squared plus 4x plus blank should equal negative 2 plus blank. Remember, you're getting all the x's on the left side with a blank and move all the constants over. The a value has to be 1 before I can complete the square, so that's good. But notice that the b value is even. Right, so that is very, very nice. When a is 1 and b is even, completing the square is pretty darn simple, because what goes in the blank is half the b value squared. So half of this is 2 squared, you get yourself a 4. And nice. Now this is a perfect square trinomial on the left side. He'll factor to be the square root of the first homeboy and the square root of the last homeboy, and then the sign from the middle. This number right here, FYI, is always half your b value. Notice he's a positive 2. That's half your b value. And that quantity gets squared. That's what the perfect square trinomials factor to be. And then add those numbers together, you get yourself a 2. And now, square root method. Square root this side, square root that side. Those cancel. You're left with x plus 2 equals plus or minus. Notice that doesn't come out very pretty. It's an irrational number. That will always happen when it's not possible to factor. So, to solve for x, there's only one more move left. We will subtract 2 from both sides, and we'll just have ourselves a pretty little answer like this. There's two different answers there. Negative 2, if my pen would work, plus the square root of 2, and negative 2 minus the square root of 2. Pretty simple to complete the square, because a was 1 and b was even in that situation. But hey, let's use the quadratic formula and realize it's really possible to do it that way. Let's see if it's easier or harder. So identify a, b, and c. A is 1, b is 4, and c is 2. And I'll talk myself through it. Opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which would be a 2 in this situation. And then I got myself a negative 4 plus or minus square root of, let's figure out this discriminant here, 16 minus 4 times 1 times a 2. I forgot the minus. Well, when you punch it in, sorry that I punched it in wrong, you get yourself 8 in that situation, all over 2. And then what makes the quadratic formula kind of crappy in this situation is, hello, we must simplify this radical. Biggest perfect square that goes into 8 evenly is a 4, and that goes in there twice. So I've just replaced Mr. Pink square root of 8 with this, and that's really negative 4 plus or minus 2 square roots of 2 all over 2. And then you have to check your triangle of death. bow, 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 these three numbers. Never worry about what's the radical. It's these three numbers. If there's a common factor between all three of them, you can reduce it, which you can. Doesn't 2 go into each one of those? So you'd be left with a negative 2 plus or minus. 2 goes into 2 one time, and there's the square root of 2 hanging out with him. So notice you have that kind of 1 in front of there, all over 1, which you don't need to have, and bada boom, same answer. You're supposed to get the same answer. It's just, in my opinion, completing the square was a much easier situation because I didn't have to do all this simplifying of radicals and reducing the triangle of death. A was 1 and B was even. I was in good shape there, even though the quadratic formula will always get you to the right answer. So, last one here of these examples before we start getting serious. Let's solve this all three ways, if possible. Let's see if I can factor this bad boy. Well, A is 1, right, and there's no GCF, so it's not a perfect square trinomial. We're rolling with easy factoring. Two numbers that multiply together be a negative 8, so the signs have to be different. 1 and 8, but the signs are different. Those don't add together to be negative 3. 2 and 4, but one of them is negative. Those don't add together to be negative 3. That's it. Those are all the multiples of negative 8, and none of them add together to be negative 3, so this is not possible. It is not possible to factor this. It is possible to complete the square and use the quadratic formula every time. But we're going to realize here that completing the square is just not very fun. So I'm going to literally write this equation down. Well, I don't need to. I'll set it up to complete the square by putting the plus blank. Sorry. Add 8 over. And now, this is why complete the square is not so nice here. A is 1, right? So that means I can do it. But now I got to fill in the blank and take half the b value. And oh, Snapplebees, my b value is an odd number. So I don't want any decimals either when we're doing this. Here's what I do. I kind of do, it's not really cheating, but I kind of do one of these moves. I already know that I'm going to fill in the blank and turn this into a perfect square trinomial. And this is going to turn out to be an x. The sign from the middle comes down. I need half my b value right here. Well, that's 3 halves, right? Like negative 3 halves. Like you just divide it by 2, and there she is. And to fill in the blank, you take half your b value and square it. So now I'm like just using this as a visual so I can see, oh, I need to square negative 3 halves. Well, it's always going to turn out to be positive. 3 squared is 9, and 2 squared is 4, right? So squaring 3 halves gives you 9 fourths. 9 fourths is the number that needed to go in the blank both times. Now I got to add these together, and they're fractions, so you need a common denominator to add fractions. So since this is a 4, I'm going to turn this into fourths by multiplying both top and bottom by 4. So that gives you 32 fourths plus 9 fourths. Now you just add your numerators together, and you get yourself a nice 41 fourths in that situation. Yuck. And now let's square root both sides. So square root of this, and then I like to kind of just roll like so. Square root both top and bottom because they both need to get square rooted. Those cancel. X minus 3 halves is what you get here. You'll need your plus or minus. And 41 is not a perfect square, so he's going to be the square root of 41. 4 is a perfect square, so the square root of that is 2, and we've already got the plus or minus in front, so the denominator came out nice. Numerator square root of 41. If he can simplify, we need to simplify him, but the square root of 41 does not simplify, so, and now, solve for x by adding 3 halves over. So you get 3 halves plus or minus the square root of 41 over 2, which usually we like to write it like this. 3 plus or minus the square root of 41 all over 2, because they both have the same denominator of 2. And you'll see when we do Mr. Quadratic Formula that it's going to be much easier to get to that answer because we don't have to deal with all these crazy fractions. So let's try the quadratic formula and realize that he's smooth in this situation. So A is 1, B is negative 3, and C is negative 8. And let's sub in. Opposite of B 3 plus or minus square root of b squared, which is 9, not negative 9, minus 4 times a times c all over 2 times a. Now let's clean up that discriminant. So I need 9 minus 4 times Juan times negative 8. And there's your 41. And remember the radical's still around him. And it's all over 2. And the square root of 41 cannot simplify. The triangle of death cannot reduce. There's our final answer. So, bada boom. And then we'd put it in solution set. You'd have 3 plus the square root of 41 all over 2, and 3 minus the square root of 41. This pen is not cooperating. All over 2. Sorry for the bad pen. But the quadratic formula was way easier in that situation. So, to our next part right here, it's like, let's write down when's the best time to factor, when's the best time to complete the square, and when's the best time to do the quadratic formula. Here's the best time to factor. Right? The best time to factor is when the numbers are small enough to deal with. Like some of these quadratics we'll see on the back side will be factorable, but the numbers are just too big. Like you don't want to spend time finding two numbers that multiply together to be 3,571 and add together to be 1,020. That's just ridiculous to waste your time with. So the best time to factor is when the numbers are small enough to deal with, and you can actually factor it, because as you saw, we can't factor every single one of them. Now if you need to pause the video to write this down, please pause the video. But the best time to factor is basically when you can do it. Complete the square. So when's the best time? When A is 1 and B is even. And you're not able to factor this situation. Because usually, I mean, it's easy factoring in that situation because you're only going to complete the square when A is 1 anyway. So when A is 1 and B is even. As you can see back here, you can complete the square on every single situation. But A was 1 and B was odd. This was nasty to complete the square with because you're going to get all these crazy fractions. And it's not like it's difficult. It's just time consuming. So the only time I'd like to complete square is when A is 1 and B is even and I'm not able to factor. And then when can I use the quadratic formula? When the numbers are just too large to factor. Like if you got these big old numbers, it's like you might as well run straight to the quadratic formula. Or when complete the square, that's what CTS, makes no sense. So when the numbers are too large to factor or when complete the square makes no sense. Like this one back here. These numbers aren't very big whatsoever, but complete the square makes no sense because B is an odd number. You might as well jump straight to the quadratic formula. So when the numbers are too large to factor or when complete the square makes no sense. So let's do that on the back side. It says solve these quadratics by the easiest method. I've talked myself through this way. Can I factor it? If not, can I complete the square? If not, should I do the quadratic formula? So all three are possible. Number 4. Can I factor this? Well, it's in the easy factor category because A is 1. Two numbers that multiply together to be negative 10 and add together to be negative 6. So 1 and 10, but one of them is negative, and 2 and 5, but one of them is negative. And neither one of those is going to work for me. It's like I can't factor this. So I want to see if I can complete the square on it. Is A 1 and B even? Yes! So it's time to complete the square. We'll set it up with all the x's on the left side and move all the constants over to the other side. And trust me, I know this is weird for a lot of people because they haven't done a lot of complete the square. You'll do plenty of it, and it's the best way to roll. So how do you fill in the blank? Half the b value, negative 3, squared. That would give you a 9. And now this factors to be x and then half your b value. It's like, that's an easier way to remember if you want to. It's like, it's always got to turn out to be whatever the letter is. It could be something other than x. And then this guy right here is half your b value, quantity squared. That will equal these two added together, which is 19. And now you square root both sides. So, popping, popping, x minus 3 equals plus or minus the square root of 19. That's usually the biggest mistake, is people forget about the plus or minus. Now add 3. X equals 3 plus or minus the square root of 19. Done. Put your answers in a solution set. I like it. Complete the square is a piece of cake when A is 1 and B is even. So let's try number 5 here. First of all, I want to see if I could factor it. A is 1, so this is not a perfect squared trinomial, no GCFs. Can I find two numbers that multiply together to be 10 and add together to be 4? 1 and 10? No. 2 and 5? No. Can't factor. So is A1 and B even so I can complete the square? That's a winner, man. So you set them up with blanks. Got to move this over, so watch out. That's going to be a minus 10. And now you fill in the blank with half the B value squared. So that would be 2 squared, which is 4. Come on, pen. And now this will factor to be x plus 2, right? Quantity squared equals negative 6. Uh-oh! Time for some imaginary answers, because now we've got to square root both sides. Popping! Popping! So x plus 2 is what we get over here. You're going to need the plus or minus. Just pretend that this was a positive number for a second. Like, is the square root of 6, is 6 a perfect square? No. So you know you're going to have an I popping out of this situation, and then you got the square root of 6. And the square root of 6 cannot simplify, so that's plus or minus I square roots of 6. And now to finally solve for x equals negative 2 plus or minus I square roots of 6. Solution set. Negative 2 plus I square roots of 6. Negative 2 minus I square roots of 6. So, nice. Next, let's see here. Factor. Well, that would be a frowny face situation, right? So I would need two numbers that multiply together to be negative 21 and add together to be 12. So 1 and 21, but one of them's negative. That won't work. 3 and 7, and one of them's got to be negative. That's not going to work. Can't happen. I cannot factor this. So, alright, cool. You don't have to erase that if you don't want to. Complete the square? No way, Jose. A is not 1, right? A's got to be 1, and B's got to be even. So no way. It's time for quadratic formula. And I don't care if you put this A equals B equals C equals off to the side. I like to do that. It's just the way I've done it for years. So if you can get the numbers in the right place, I don't care. So opposite of B, plus or minus square root of B squared minus 4 times A times C, all over 2 times A. Be careful. A lot of people just always put a 2 down there. It's 2 times A. Now let's figure out what this discriminant is right here. Ba-ding! Let Mr. Calculator do the work for you. You can punch that in real quick. And I hope that you got the discriminant to be 228. And now we've got to simplify the square root of 228. So to find the biggest perfect square that goes in there, you work yourself backwards. Oops, negative 12. And it just so happens that 4 is the biggest perfect square that goes in there evenly. So when you pull him out and get square root, he'll become a 2. It went in there 57 times, all over 6. And then you check your triangle of death. Boot, boot, boot. Those three numbers do have a common factor of 2 in them. So that is negative 6 plus or minus 1 square root of 57 all over 3. And then the solution set, negative 6 plus the square root of 57 over 3, negative 6 minus the square root of 57 over 3. Hey, many of you probably have a good question. They're like, Mr. P, can't you reduce this negative 6 over 3? Well, realize that this number right here is a 1. So like all three of these numbers have to have a common factor, and like 3 doesn't go into that. 3 is bigger than 1. So just leave it like that situation. It's called the triangle of death, or I call it the triangle of death, because all three numbers have to have a common factor for you to be able to reduce. 7. Let's see if we can factor this. It'd be in the frowny face category, since that's not 1, so negative 3. Can I find myself two numbers that multiply together to be a negative 3 and add together to be negative 2? Well, one of them has to be negative, so winner! I can factor this. So 3x squared comes down. I'll put the minus 3x plus x minus 1 equals 0. Double group. Bloot, bloot. Come on, baby. Bloot, bloot. Take the GCF out of each group. 3x can come out of this group. And the GCF that comes out of that group will be a 1, and he's positive. And that will equal 0. Regroup the GCFs as a group of their own. So 3x plus 1 times the x minus 1. And 0 product property. X equals negative 1/3 or 1. Even though we always get kind of cranky when it's time to factor, we're pretty darn good at factoring by this point, so really it's pretty slick to factor that. You could have completed the square, you'd have to divide everything by 3 first, you'd get really nasty numbers, you could use a quadratic formula. I don't know, I think factoring's faster than using the quadratic formula. We're smart. Alright, let's try this guy. Factor. Let's see, it would be in the easy category. Can I find two numbers that multiply together to be 2, and add together to be 2, and 1 and 2 multiply together to be 2? A lot of people say 1 and 1. Guys, 1 and 1 multiplies together to be 1, so that doesn't work. There are no numbers that multiply together to be 2 and add together to be 2, so not happening. Complete the square. Is A1 and B even? Yes! So I would like you to pause the video and complete the square on this guy. Let's see if you can get him done. Alright, so if you set them up with blanks, you have to subtract the 2 over and fill in the blanks. And you get 1 to fill in the blanks because half the b value is 1, squared is 1. Then this factors to be x plus 1 quantity squared. That'll equal negative 1. So you should get imaginary answers because the next move is to square root both sides. And when you square root this, you get x plus 1. And then here, guys, realize the square root of negative 1 is I. Don't put I square root of 1 because, guys, the square root of 1 is 1 right there in blue, so we don't need that. And then you just subtract the 1 over, and you get negative 1 plus or minus I, and put that in a solution set. 9. Let's try him, man. Let's see. Hey, is this a perfect square trinomial? Is this a perfect square? Yes. Is this a perfect square? No. So maybe I can easy factor him. He's not a perfect square trinomial, though. Two numbers that multiply together would be negative 9. That'd be 1 and 9. One of them's negative. That's not adding together to be 16. Or 3 and negative 3. That's not adding together to be negative 16. So nope. It's down to either complete the square or quadratic formula. So this right here is a complete the square situation. Plus blank equals 9 plus blank. Filling in that blank right there, half the b value squared. Half b value is 8. Squared is 64. So putting ourselves a nice 64 in each one of these bad boys. And then that'd be x plus 8 squared equals 73. Square root both sides. Plus or minus square root of 73. You can work yourself backwards to see if that can simplify. He's not gonna. So x equals negative 8 plus or minus the square root of 73. Done. Solution sets. Negative 8 plus the square root of 73 and negative 8 minus the square root of 73. So, pretty slick. 2 more. So right here on 10, let us see if we can factor. That's always the first thing. It'd be a frowny face situation, so that's negative 14. Can you find two numbers that multiply together to be negative 14 and add together to be negative 13? Well, you bet. Right there. So 2x squared minus 14x plus 1 x minus 7 equals 0. Alright, I will let you finish frowny face in this bad boy. So pause that video and see if you can get what I get. And I'll let you check your work accordingly. I got negative 1/2 or 7 as my two solutions to this quadratic. Hey, last one, baby. Last one right here. Let's talk about factoring. Maybe But it would definitely be a frowny face situation, and I could care less because these numbers are too big to deal with. Like 25 times negative 9, that's going to be a big old number. I don't care. So I'm skipping over factoring. Complete the square? A's got to be 1, and B's got to be even. A's not 1, so you'd have to divide everybody by 25. So it's time for the good old quadratic formula. So this is a no-doubter in my mind. These numbers are too big to deal with because it would just take too much time to find the two numbers. So we might as well just do the quadratic formula. Negative 40 plus or minus b squared, so you can punch that in if you're not sure, but 40 squared is 1600. Minus fur times a times c all over 2 times a, which is 50. Let's find this discriminant by punching all that nonsense in my calculator. So 1600 minus 4 times 25 times negative 9. 2500. Ooh, I like that number. He kind of seems like he might be a perfect square. If you're not sure if that's a perfect square or not, you could now square root him. So the square root of that previous answer is 50. So the square root of 2500 is really 50. Since that discriminant was a perfect square, that means you could have factored this. This was totally factorable if you wanted to, but take too long. So now the hard part about these is setting up the two answers. You got negative 40 plus 50, which is 10. That's still over 50. I could care less about reducing this right now. I'm just going to write my two possibilities. And then negative 40 minus 50, which is negative 90 over 50. And now I can reduce these. The zeros cancel out right there, and you're left with 1/5 or negative 9/5. So this was factorable because I got rational answers. But it would have taken a tremendous amount of time to find the two numbers for me to factor this. I could have just done the quadratic formula in the meantime. So folks, I know there's one more left, but I think we get the point by now. It's what's the best way to solve the quadratic? Hey, let me know if you have any questions, and have a good one.